this video, we are going to discuss about servo tracking ADC. It is nothing but an advanced version of the counter type ADC. So in the counter type ADC, we have only up counter, whereas in servo tracking ADC, we have up down counter. So in what is the disadvantage of the counter type ADC is, since I have only up counter. So if you see, this is my analog signal means this is my analog signal means since I have only up counter, so it will track my analog signal like this. Okay, so once if it find this point, okay, so you can see though my analog signal get reduced. Okay, so once if it reaches the maximum point, suppose if it is a 3-bit counter, so it will count. So and if the maximum value is 7, it can track, right? So if it reaches 7, okay, so it will goes down, right? Since it is a counter, so it will count from 0 to 7. After that, it will go to 0 to 7, right? So again, to determine this value, it will go like this, right? It will tend to track this point. Okay, so this is a disadvantage of the counter type ADC. So whereas here we have up down counter. Okay, so by using the up down counter, I can go up and down direction. Okay, so this circuit consists of an up down counter. It will be controlled by using the comparator. So if the VA value is greater than VD means my output of the comparator is 1. Okay, output of the comparator is 1, so it will start to up count. Okay, whenever the VE value is less than VD, so you will get the output of the comparator as 0, so it will down count. Okay, so the DAC output increases with each incoming clock pulse, right? So if I have 1 means initially the value of DAC, the up counter is value is 0. So whenever if I have 1 means it will start to count, right? From 0 0 0, it will goes to 0 0 1. Okay, till if I have 1 means it will start to up count. If it is 0 means it will down count. Okay, suppose if the value is value of the digital output is 1110 for 4-bit, if I get 0 means it will start to down count. Okay, so what will be the values? Okay, that is it is counting in the reverse direction. Okay, and the change, right? So you can see this change is nothing but 1 LSB, right? Again, if suppose if it is down counting means will start to down count means, so this change is nothing but 1 LSB, plus or minus 1 LSB. Okay, so you can see this is my analog input, analog signal, blue color line, and I am going to track this one. So okay, so since the VD value is less than, since the VD value is 0 initially, so the output of the comparator is 1, so it is tracking my my analog signal. Okay, so it is tracking my analog signal. So till this value, my it is up counting. Okay, so this 1 represent up count value, and this 0 value represent down count. Okay. So once it reaches the value, so it start to down count, right? So since it is down counting, and again it start to up count. Okay. So up count, then down counting. So you can see this process goes on repeating whenever the digital output change back and forth by 1L plus or minus 1 LSP around the correct value. So if the process will be that the tracking will be of correct value whenever the change in the analog input is very slow, and that is within the 1 LSP value. So if the analog input changes rapidly, so if you see this condition, okay, so if the analog input is changing rapidly, means there is a possibility of tracking error. Okay, that is it cannot keep up with the changes. So therefore the tracking of the ADC cannot keep up with the changes. So therefore the error will occur. That error is called as a tracking error. Okay, so the advantage of this servo tracking ADC is it is very simple, but the disadvantage is the time need to stabilize. The time need to stabilize as a new conversion value is directly proportional to the rate at which analog signal changes. So the tracking ADC is dependent on my analog signal value. Okay, so if the analog signal value is more, means the tracking time is also more. Okay, if it changes rapidly, means there will be a tracking error. So that's all about the servo tracking ADC. I hope this video is useful. So we will see in the next video. Thank you.